Rád by som privítal Martina Beránka z EKI a porozpráva nám o nočných morách ohľadne operácií z gRPC. Tak jo, je to tvoje.
Thanks. I actually announced the talk as being in English, and I think it's just a better option for you since I'm from Prague, so nobody from like Prague and like 30 kilometers more or less understands those people anyway. So I think English is much more better alternative for all of us. And I'll be having this wonderful, really positive talk about gRPC operations nightmare. It's going to be like 30 minutes. And since we are still close to the break, this is like the content part where you can find out if you still have the time to leave and maybe grab something more to eat. I'll be talking a bit about motivation for gRPC. I'll discuss traffic and how to use a correct runtime for the traffic, and then we'll talk a bit about monitoring. So hopefully you'll enjoy it. Okay, so what's the motivation? And since I'm infrastructure lead, I used to be called like a DevOps engineer, which is kind of weird because DevOps is a culture. I wanted to make this a bit fun. So this is a photo bank picture called Image of Excited Programmer when showing thumbs up. So that's how the developers usually looks like when they discover something new and they want you to develop or prepare the infrastructure. Or maybe that's just the way the world actually imagines the programmer look like when they're doing something exciting. Haven't seen that face for a long time, but okay. Then come the bargaining part, we are already running it. Okay, so what's the problem? We felt uncomfortable to tell you in the first place. Okay, that's DevOps right there. That shouldn't happen at all. Customer agreed on it too. Again, I don't understand where is the problem and how should I help. And of course, Google uses it, which is kind of true for gRPC. Google is a huge adopter. So that's something really interesting for me. So now let's get a bit serious. So what's the important part? Well, for me, especially as the guy from operation or SRE or whatever buzzword do the trick these days, for me, the important part is the SLA, and with that, the objectives we have to follow. So basically, that's like availability, latency, throughput. And that's something which is more or less meta for any protocol you are going to use. So yeah, as you already see, I have a weird, I really like the pictures from photo banks, so thumbs up. So for me, like the objectives usually are the availability, which is almost always 99.99, which is like 4 minutes and 22 seconds of downtime a month, which is quite okay. gRPC is not going to help you there. But that's something to work with. For latency, gRPC is natively running on HTTP v2, so that's slightly better due to usage of binary transmission and so on. But it usually doesn't matter because all the bottlenecks are like lying in the databases or anywhere else than your protocols. So it usually does not really have any sense to discuss it with the developers in the first place. And throughput, again, since gRPC is driven by HTTP2, is slightly better because of the binary format. And for following the operations requirement, let's say SLA, SLE, SSR, SLO, we usually have the tools to use that, to use on it. That's something concrete, and that's something we can work with. So those are the load balancers, TLS, Kubernetes, Cloud Run, and whatever. So now, when we know the requirements and what should be taken care of based on the operations part, let's discuss a bit about traffic. First of all, everything in gRPC routed to your load balancers is just an HTTP post. There's nothing else. If there is, let's say, head request or options, options are usually called in like CORS header setups, and those usually do not relate to gRPC at all. Other than that, you are just dealing with the posts, and that's it. of course, there is like a huge difference in between running gRPC in your browser and in your native apps, let's say on your Android device or in your iPhone or whatever. And since support for browsers is fairly limited, there is somewhat an extension called gRPC Web. And it's there because browsers have a hard time to fully enforce HTTP v2 as a standard. So you're kind of forced to have some kind of middleware, some kind of proxy, which is taking care of these slight issues with regards to the browser. But for our use case, usually we try to have like one backend running all the resources, providing all the data for our front end, for our apps. So we kind of wanted to have everything in one backend. So for us, gRPC Web was the only way to go. As I was saying, like since everything is post, you kind of have to keep your static data somewhere else. So almost everything you would use HTTP GET have to be hosted on I don't know, like some normal HTTP endpoint or in normal CDN. So it kind of means the point of having like one source of backend data, but that's something you have to deal with. To further empathize the point with the HTTP post, you can't just curl the data. Well, you can do that, but the output is going to be in binary. This is the copy-pasted curl command from Flash News, which was the project we used gRPC for. And it just says that the output is going to be displayed because it's in binary. So if you are okay with that and it's not going to break your terminal, you can just put their output. That's all right. Other than that, you would have to use some other tools like, let's say, Bloom RPC, where you can import the schemes from protofiles, and then you can ask the backend for the data, and you can have those. If your backend can provide a reflection, that's much easier for you because usually you don't need to import the protofiles in the first place. But let's try to do that in the middle of the night when you are trying to debug some kind of incident, and you do not have the latest protofiles with you. So that could be something to get really bothered with. About traffic management, I'm going to describe like what we did for Flash News. We used Cloudflare as an CDN, which I'm going to describe is not really helping that much. We wanted to have a platform which takes care of almost everything for us. So we picked GCP because we kind of thought that the support from Google is going to be 100% since they are using it on almost everything. So that's going to work for us as well. And then we had to provide something for proxying gRPC Web. So for that, we used Envoy. So how is it with the Cloudflare support? Well, it's there. You can enable it just by switching a button, like cool. But it's kind of supported-ish. You have your web application firewall, bot management, page rules, which, without page rules, you are usually screwed in Cloudflare anyway. But you have no Argo tunneling, no Cloudflare access, and no CDN. And that no CDN part is obvious since you can't really cache anything from HTTP GET. There are no GETs in the first place. About GCP Load Balancer, there is hardly anything to look at. You need to enable HTTP v2, which is, I think, by default enabled. And there's one small issue with health checks. I have a few slides about it in the presentation as well. And then there is Envoy. And I'm going to talk about it in the detail a bit, but it's like the configuration is usually written in YAML. And Envoy, in the first place, I don't think that it was mainly designed to be managed manually by anyone, anywhere. I think it's just a good sidecar for Istio, and that's mainly it. I prepared an example of the configuration we had, and don't worry if you can't read it. It's just 4 slides of never-ending configuration. I don't know, like if you have like a personal experience with it. And if you try to debug anything in Envoy configuration, yeah, I kept that there. It's a private key. You can try that. Yeah, but it's not really fun to debug. Not really fun to play with. It's just long, And I had like few points which I wanted to mention. And after like trying the presentation for the first time, I thought, yeah, no, let's describe it afterwards. So in there was like 4 lines for gRPC web filter setup. That was important. There was self-signed TLS certificate setup. That was the private key. That's there just because we wanted to have HTTP v2 enabled from the backend. There was like an admin endpoint for the debugging and core server setup. Core server setup, I don't know like how about you, but usually we liked backend developers to manage it for us. So it was somewhat a surprise that we had to show them like where it's set up in the Envoy, and they can then do it for them afterwards. But it's not as easy as it is like for example, in Node.js Express framework. How about runtime? Well, since I was saying that managing Envoy on your own is kind of hard to do, we felt that we'll adopt Istio. Why not? Since it's like a service mesh, it's fancy and everybody likes it. So we kind of felt that we don't have really the time and the money to spend on something we would like to manage on our own. So we were happy that GCP introduced something called Anthos. It's just an Istio managed by GCP. They have an SLA for it. It's easy to set up since you are already paying for it. It has a different billing model. It's paid by CPU cores. And yeah, you can roll with that. And it's, as I was saying, it's kind of expensive. As you can like deploy it for the first time, it doesn't let you deploy anything small than 2 nodes with at least 4 CPU each. To roughly translate the sentence from my colleague, it says no poor person allowed. But after that, the whole Envoy setup I was showing you before is taken care of by MTLS, by the control plane itself. So then definition of gRPC web service is just done by saying that the service port is named gRPC web and then your name you would like to use. So that's really simple. There's one other option. You can actually state a protocol. It's presented in Kubernetes from 1.18. Never worked for us. I don't know, maybe it's just a constraint from Google. But it could be done, and it's much simpler and much smaller. But again, it's service mesh. So you have to be ready to increase the complexity. Sometimes it's really hard to debug until you deploy some other tools which can help you with that. I don't know, like for majority of the use cases and projects, saying that you are going to deploy service mesh and it's going to be Istio, and a lot of people start to be, worried just by hearing like service mesh Istio. Isn't that going to be expensive? Well, probably, but it's the gRPC. Google uses it, as you told me at the beginning of the project. So the question is like, do you really want to use service mesh for that? I don't know. So there are some cheaper alternatives in the Google Cloud. It's called Cloud Run. I think it's like in AWS, it's like UpRunner or something like that. I'm not, making any commercial around here. I'm just explaining how it could be done. But again, there is wonderful support for plain gRPC. You can use it without any problems. There is actually support for health checks. But there is one issue, gRPC web. This one little thing needed for the browser, that's not really there. It's not present. You have to deploy Envoy as a second service and proxy it for the first service, which kind of creates, a double spend. We are always asking Envoy to get your data from the original service. So you're like paying twice as much as you should have in the first place. And just enjoy the debugging. If something fails in the middle, you are just screwed. It's going to take a while. How about monitoring? I was at the talk which was here before my talk, and it was saying that all of these SRE talks are usually very negative. I can see why. So I was saying that for load balancers, there is one little thingy about the health checks. This is the setup in GCP. It's nice, but you can't edit it. Cool. I don't know why, but you can. There is one other problem. You can't create the health check in the first place. So now you can be asking, like, why did you manage to even have it there in the previous slide? But you can do it through the API. Like, you can create a Terraform resource for a health check, say that it's going to be monitoring gRPC endpoint, and Terraform will happily provision it in a GCP cloud with no issues. I was checking if this is just some UI bug or something, or maybe it's not supported in some regions. I had no luck. Asking on support seemed to me like, I don't know, not a nice thing to do to the junior support engineers. So we just have to roll with it. One other thing, logging. As I was saying, you are still using method post. So you are not really having any additional information out of reading the logs from the load balancer. It's always going to be the same method. Fun part is the request URL, where you are having the endpoint which is called at the backend. So that's something you can work with. And then some private information like remote IP, server IP. Those are again proxied from Cloudflare, so they are not really saying that much. So as you are used to having some more information from the load balancer, for gRPC, it kind of narrows down since it uses the HTTP more or less as a transportation layer rather than part of the application. You kind of have to step up your game in the container logs. So this is the example from the slide before, but from the point of perspective of the container. So here you can see all of the headers, the payload which got transmitted, who was the user, what was the endpoint called, and lots of other small important details you kind of need in your work. So in a way, the load balancer logs are usually important just when you are debugging the issues related, in the connection from the load balancer to the gRPC backend. It's not really helpful at all. And one other thing I would like to point out, I have the slides about it after this as well, is status. It's up there in that JSON. gRPC actually has different status codes, not like HTTP. So that might get a little bit complicated. One other thing, gRPC is really good with streams, not really for gRPC web, but you can also open streams from the browser to your backend as well. But these are the issues you usually have with any streams endpoints you are hosting in your WebSockets or whatever you would like to use. So for gRPC, you have to create something. Well, you have to think about clients willing or being able to reconnect in case the stream is going to hang up. Never-ending story for the developers is that usually they open more than 6 connections, and that's the limit for Chrome. And I think I handled 3 or 4 tickets of asking if I can enlarge the number of connections to the backend, because it always hangs up at 6 connections. And it always, I actually found a ticket at Chrome support. I was just sending that to them. That's not the issue of the backend. It's just an issue of Chrome or any browser in that matter. And of course, always discuss the deployment of those endpoints with the developers, since this is the example of the endpoint we are monitoring, and as an operations, we wanted to have some kind of alerting if the latencies are going to above given threshold. And in here, you can see that streams do not really, work in this matter. So like it's obvious that something on the way got a limit of 30 seconds. So at least we got the alert that the endpoint, got the threshold above. I don't know what was the threshold, but it reached always 30 seconds. So after that, we were aware that something new happened, and there was the new endpoint for the streams. And we kind of had to remove it from the monitoring and figure some different way how to see how the requests are actually managed and how we can monitor it in favor of the user. This is the slide about custom error codes. This is the example, there was the alert saying that the backend service has some kind of the issue, and I thought, okay, so I'm going to copy curl command from the browser, from the network tab, and I'm just going to look up what's wrong, and just pasting it to the terminal. I've seen that it transmitted all right. I got my HTTP 200, so I felt like, okay, so backend is all right. One other thing is that, as I was saying, gRPC has their own error codes and status codes and so on. So there's the second light from the end saying that gRPC status was 13, which is just saying that my request and the backend who was handling it was trying to access the memory, which is outside of the buffer bounds. Cool, but again, it's kind of hard to detect because this is happening at the application. So you kind of, again, have to revisit your container logs, create some kind of log-based metrics, or at least have some Prometheus endpoint with correct counter and react on that rather than relying on the HTTP and the way how they are propagated, how they are propagating the error codes. Is it really that bad? As you've noticed already, from my perspective, it wasn't really that optimistic. It's just part of my job, look for the things which can broke. And I think I had this claim, the world has to rest. It's not really funny after all, but it felt funny for me, and that's enough for me. So I think it's just disrupting the whole process, how you can feel and work with the application and the traffic management in the first place. It's just wonderful thing that you can just import your protofiles, let gRPC plugins and SDKs generate the code for you, and work with that without even visiting some Swagger documentation and so on. So this is actually really amazing. So if you are willing to work with that, you have a use case for it, you are quite okay with living through some issues like configuring Envoy and so on. I had these examples who is using IPv6 these days? Hopefully all of us, but the way why we are using it is just because it's really easy and it's done for us, which is not currently really true for gRPC. And in a way, it's here since 2015. And even so, it's adopted by all of the major projects I can think of, for example, Argo CD and Argo in general. So it's not going away. So that's good. At the end, we ended up with having Istio on Anthos. As I was saying, customer was willing to pay for it. Cool. And we use Argo CD for deployments to, let's say, alleviate some kind of hard work from us. So it actually worked. And that's the way I would recommend it for you. So it's just not bad at all, as I was trying to explain in the past 2-3 slides. It's just your use case might not be good enough. So for us, the good use case was having lots of Android devices, lots of iPhones, for which developing the applications the DX experience, developer experience, was much better because of the gRPC. And for us, it was just a hassle we had to put up with. So when is it useful? It's just a recap of all the things I was saying. If the request couldn't be cached, you would be using HTTP post as well. So why don't you use gRPC for that? It's just nice integration with almost every language, which is also cool. As I was saying, you just download the protofiles or just use the reflection, and the code is being generated for you. And there are like traffic improvements because by default, although natively it's running only on HTTP v2, which is amazing protocol to use in the first place. So that's it. Thank you for being here. Hopefully it wasn't that negative. Last time I finished the talk like this, somebody then asked me if I want to kill myself every day. For that, I would like to recommend you the lecture which was before me in here. Hopefully it was all right and you found out something which was interesting for you. Thank you very much.
Perfect. Thank you very much. We have like no questions at Slido. So do we have some here in the audience?
For some reason, I'm not surprised.
What is the reason? Okay.
Thank you.
Wait a minute. I get it. Mike.
So yeah, as far as I understood, troubleshooting and debugging all of these gRPC request stuff, if something went wrong, it's quite non-trivial task, let's say so. Yeah, and have you like developed any in-house built instruments or tooling that simplifies this life, or using some kind of upstream stuff, open source stuff?
Well, you can always use the tools you would use in the other protocols as well. Like tracing was always working. It kinda like show the endpoint's name in a way they would be displayed for like HTTP call. So if you would understand like what the call was about, the name of the endpoint, so like tracing was always useful. We tried not to really like develop anything ours because we felt that it's going to take us a lot of time, and at the end Google or some other people would do it much better than us. And it kind of happened like multiple times. We were like deploying the health checks, and after like 2-3 months Google came up with their own health checks, even though they are really hard to deploy, as I was showing in the slides. So we kind of like played the waiting game, and most of the cases it worked for us really well. So it kind of got implemented in the process. Yeah, as I was thinking about it right now, I think it's kind of slowed down the adoption and all of the development of the project, because we were not really sure like if we are able to put it into the production and we have enough information for debugging it. So we kind of wait at the beginning. We did like extra benchmarking. For example, K6 benchmarks, they have wonderful support for gRPC as well, so that can be used. And from that, we had enough information and enough data to be, sure that it's not going to fail after the first day being in production. So yeah, like the short answer would be that no, we try to use the tools Cloud already have, and most of the time it worked for us.
Cool, thank you.
Thank you very much for the question.
Okay, any other question? Well, okay, so we're going to close that. Thank you very much again for the presentation, and we can have a short break.
Thank you.